Always great to meet a curious bunch of folks coming together and trying to learn something. Great things happen in that scenario. Um, okay, cool. Yeah, I think I'll just briefly start by talking about Sarvam and maybe what we can do for you. I think Sarvam is a foundational AI company. We are trying to work across the stack, right from GPUs. We own our own GPUs. We don't use third-party GPUs to building our own models. We build the barebone models, which is the speech models, text models, translation models. Then we build our own LLM model, and then we also work on applications on top of this. We have multiple areas of focus. One of the areas of focus that we have is conversational agents as a product, and I've spent about maybe last 1 year trying to be in this space and trying to figure out what it means to build conversational products, what is going well, what is not going well, and how we can get about it. It's a very broad topic, conversational agents, and each individual topic itself can be covered for an hour. But I will just take this time to give you a slight overview about the tech, maybe where things are and how you can think about them. The idea is if at the end of this, if you're working at a company, if you have enough confidence to be able to understand what does it mean, when to use, when not to use, I think that's a good takeaway for me. Um, Before I get started, I just also want to understand a bit about the audience. So I'll just present this and hope that it works. Are you guys able to see this? Can you maybe join here and then I'll just have a couple of questions that I can understand. Okay, all right. I'll just move ahead. Hope you guys are able to um, see the first thing. Are you guys able to see the question? I can see it. Uh, okay, okay. Most of the folks are from product and design, and you're founders. Okay, cool, got it. Okay, got it. No, that gives me a good sense of maybe what I can cover and which level of sophistication I don't want to go into. Okay, I'll go back to my presentation. I just wanted to get a sense of maybe how I want to tackle the rest of the session. Okay, then in that case, what I'll get started with is maybe talking about what is happening with voice agents. Why are we speaking about voice agents now? Why not so far? What happened maybe 2 3 years far, and what has led to this moment where we see voice agents coming in right now? And most of you might be aware of some sense of this evolution, where initially we saw this Google Now and Siri existed. The way that these things were generally trained on was being very command based. So they were not designed to be conversational; they were just designed to be command based. And the way it would happen is, for example, they would say that, hey, I want my voice agent to do these 10 skills, like set up an alarm and maybe call person X, etc. They would just take set up an alarm as a thing, and you would create 100 variations of this. So you'll say, hey Siri, can you set up an alarm for me? Hey Siri, I want to wake up at 6 o'clock. Hey Siri, I want to do ABC, etc. You set up 100 things of it. There used to be techniques called bag of words or classifiers. So it will just say that all of these classify to alarm, and it would just classify that. And if it fell into any of them with a certain confidence, it would do that. That is where it has initially started. 2016 to 2020 was the evolution of bringing this out of the phone into physical hardware devices. And second, going from 10 skills to about 100 skills. So if you have played around with Dialogflow, it was a very initial version of Google Assistant being democratized, where you could build slightly more complex intents, typically about 4 to 5 commands, etc. And those were the things that you were primarily training them on. But I think even with Alex or Siri, I think most of the people's experience has been that you were trying to say something, it would not get it. It would always go back to saying, "Sorry, I couldn't understand what you said," and it was because the speech recognition was not there, the intent classification was not as strong. Majority of the improvements started coming in from 2021 to 2023. So I think the overall speech recognition got much better. So Google has started using a bunch of YouTube videos, started doing YouTube subtitling quite a bit, and that has meant that across languages it has started to get better in understanding what the user is saying. This is why I think you would have generally seen subtitling quality get better from 2021. Your TV, where you go and search via voice, the voice recognition started getting better. This was one important thing that had to happen for things to happen. Second, the architecture in which you are trying to do deep learning for 2015 and 2020, like I said, was a classification model sort of a thing, or very primitive techniques. 2021 onwards, GPT-2 and other things have started to come out. So we started seeing 3B models and 7B models come out. And so we saw very initially slight set of improvements coming in. Obviously, 2023 end is when GPT 3.5 has launched. And cut to maybe where we are in the last year and this year, we saw a bunch of more improvements, which is LLM reasoning started getting stronger. So for this entire tech to have landed, two things are very, very important. One is that what the user is saying, can I capture it very, very clearly? So I say something like, "हाँ मेरे को एक burger order करना है." Can it really get that sentence right? That was one thing that was typically much of a challenge. It is much better today, but continues to be a challenge. The second thing is, once the user said this, which is "मेरे को burger चाहिए," what should happen? And there are 100 different possibilities. You have burger, you don't have burger, you're not even a restaurant, and so many things. How do you think and reason and get back to the user in something that makes sense, which is the LLM part of it? We saw significant improvements in both the speech recognition part of it, and we saw good recognition coming back we saw good improvements happening in the reasoning part of it, which how do I tell a model that this is what you should respond? So I think that's where we are today. We are seeing a lot of, and hence I think we see a lot of agents being built out. Where I think we will get to from here is, and I will talk about that in a minute, is that today voice agents are built by sequencing a bunch of models. I think we will see all of them collapse into a single model. Maybe I'll go deeper into that. But that's maybe so far of why we are hearing about voice agents right now and not before. Two major improvements. One is speech recognition getting better was very, very important. Second thing is reasoning part had to get better, and that is happening with LLMs, which is why I think we see this overall orchestration coming together. I will take one step back, which is while we are talking about voice agents, just try to think of them as conversational agents. The idea is that you want to engage in a conversation. It could be a business to user conversation. If you do it via voice, which is voice in, voice out, it happens to be telephony, it happens to be voice agents. But typically, you could think of deploying these anywhere. For example, you can think of the same architecture and the same modalities being deployed on WhatsApp. You can think of the same ones being deployed within Slack, within your Microsoft Teams, within your website, within your native applications. You will see conversational agents come in. So a lot of the work is very common when you want to think about it across stack. It's the same architecture that you use. Voice agents present to you new problems in terms of speech recognition, changes in language, and how do you output this speech. And both of them are also going to add complexities of latency, different language understanding, background noise. So you want to figure out how that works. But otherwise, when you think of voice agents, 90% of the work is going to remain common for all conversational agents. So you can think of deploying this across. Today, we see in telephony these conversational agents being deployed for both inbound and outbound. outbound is very, very interesting to businesses because it's the first time where just like SMS or email, they're able to reach to 1 lakh, 2 lakh, 10 lakh customers. If you had to do this manually, it used to charge quite a bit. To give you some sense of numbers, a manual agent, conversational agent would charge around maybe 7 to 8 rupees per minute. Whereas with AI agents, you're able to get down that to 3 rupees or 4 rupees. And I think it's a as an industry, it's a very, very growing industry in the sense that we don't see that hey, voice agents are coming, so human agents are not going to be there. We see the opposite happening. So in a lot of cases, businesses are able to provide manual support, but only to a limited set of audience. There's a bunch of audience that they want to reach out to, that they want to provide support for, but because of cost constraints, they don't do it. And making it AI based is actually growing the overall pool of customers who are able to get the right kind of service. Then we are saying WhatsApp. WhatsApp is very interesting. Still very, very early successes, not that much going on in WhatsApp, but I think very, very powerful surface if people are able to figure out how. WhatsApp also provides you that UI buttons and things that make it even more interesting. Second, I don't know how many of you guys know, but WhatsApp is going to launch business calling and support for agents. So right now, business are just sending you these things. You're not able to. You can talk to them via chat, but just like how you call a customer, how you call your friends on WhatsApp, you'll be able to call businesses, and WhatsApp is allowing AI agents to be there on the other side. It's a very big bet that WhatsApp is making. So we'll see voice agents come to WhatsApp also. If you're a founder exploring something, there's that could be a big opportunity. Third one, we are still seeing very, very early signs in web app Slack teams. These are very untapped, but a lot of powerful things on Slack and Teams specifically. If you can think of conversational agents for productivity, there's a lot that can be done on web and app. No one is thinking about this, but whatever you had earlier, the intercoms, the fresh tests, etc., relooking them from an AI first perspective could be very interesting. I'll start with the demo on telephony. This is maybe just for us to get started in terms of what we are going to cover and for you to understand. Maybe let me see.
नमस्ते, मैं सर्वम फाइनेंस कंपनी से नेहा बोल रही हूँ। आपको याद दिला दूं कि सलोनी के नाम से 20th मार्च को 1093 रुपीस की EMI ड्यू है। क्या ये सही है?
हाँ सही है।
शुक्रिया। लास्ट डे की रश से बचने और ड्यू डेट पर कोई प्रॉब्लम ना हो, इसलिए क्या आप अपने ड्यूज इमीडिएटली क्लियर करना चाहेंगे?
तुम्ही मराठीमध्ये बोलू शकता का? मला हिंदी तेवढं समजत नाही.
मी लँग्वेज मराठीमध्ये बदलली आहे. शेवटच्या दिवसाचा गोंधळ टाळण्यासाठी आणि ड्यू डेटला कोणतीही अडचण येऊ नये म्हणून तुम्हाला तुमचे ड्यूज लगेच क्लिअर करायचे आहेत का?
लगेच तर नाही होऊ शकणार मॅम. पैसे नाही आहेत माझ्याकडे.
समजले. तुम्ही 20th मार्चच्या ड्यू डेट पूर्वी रिक्वायर्ड बॅलन्स मेंटेन करू शकाल का?
नाही सांगता येत नाही मॅम. माझी सॅलरी नाही आली आहे, तर प्रयत्न करेन मी.
तुमच्या क्रेडिट स्कोअरसाठी ड्यू डेटला किंवा त्यापूर्वी ड्यूज क्लिअर करणे फायदेशीर आहे, हे मी तुम्हाला आठवण करून द्यायचे आहे. यामुळे तुम्ही कोणतेही ॲडिशनल फीस भरायची गरज नाही. तुम्ही तुमच्या अकाउंटमध्ये रिक्वायर्ड बॅलन्स मेंटेन कराल का? जेणेकरून या EMIच्या ऑटोपे सक्सेसफुली प्रोसेस होईल.
हा मी प्रयत्न करेन मॅम.
तुमच्या कन्फर्मेशनबद्दल धन्यवाद. तुमचा दिवस चांगला जावो.
Yeah. So yeah, I think there's a bunch of things happening under the hood there, in the sense that you saw one that it was able to have a conversation, and there were some instructions about how it should handle. It was nudging the customer to be able to do its stuff, etc. Second, you saw that during the uh, during the conversation, it was able to switch language based on the user request. We showed it for one language, but we actually support this for 11 languages. And so I think language switching specifically will be very important in the Indian context. Third, the voice that you're seeing is a cloned voice. So each brand is able to clone their own voice and then get the kind of voice that they have. And this one voice can speak across languages very fluently. So when you switch from language to language, you won't even notice the difference. It handles interruptions. It's very less latency, etc. And just by using a few, like whatever demos I show here are 1-2 versions behind what we have in production, so that I'm not putting too much of stuff out there. But yeah, I think just think of how you can make this very ambient, in the sense of give it a customer care while a background noise, and you wouldn't even notice whether it's a human, whether it's an AI agent, etc. So I think there's a bunch of things that you can do under the hood, and a lot of interesting applications that are happening overall in telephony. I will also just give you an example of maybe what's possible on web. Let me see if this opens up.
सकता है?
केरला जाने का सबसे अच्छा समय अक्टूबर से मार्च तक का होता है। अभी बारिश नहीं हो रही है और मौसम बहुत अच्छा है।
ठीक है। और एक क्वेश्चन था कि मैं ये देख रहा था होटल्स, दोनों होटल्स में सब एमिनिटीज है बट वाईफाई का कुछ बताया नहीं। वाईफाई है क्या जी?
वाईफाई बिना केबल के इंटरनेट से जुड़ने का तरीका है। टी वैली रिजॉर्ट और स्पाइस ग्रोव दोनों में वाईफाई है, तो आप अपनी ट्रिप में कनेक्ट रह पाएंगे।
ठीक है, ओके। एक और क्वेश्चन था जी, इसमें लोकल स्पाइस प्लांटेशन, टी म्यूजियम, डैम एक्सेट्रा में कुछ लोकल गाइड मिलेगा क्या?
टी म्यूजियम और मट्टुपेट्टी डैम घूमने के लिए एक लोकल टूरिस्ट गाइड मौजूद रहेगा। इरविकुलम नेशनल पार्क के लिए आप एक लोकल गाइड के साथ सफारी पर जाएंगे, जो आपको घुमाएंगे।
ఓకే. నాతో పాటు నా పేరెంట్స్ కూడా వస్తున్నారండి. వాళ్ళు కొంచెం ఓల్డ్ పీపుల్. ఈ హోటల్స్‌లో ఏమన్నా అమెనిటీస్ ఉంటాయండి వాళ్ళకి?
టీ వ్యాలీ రిసార్ట్, స్పైస్ గ్రోవ్ రెండు వీల్‌చైర్లకు అనువుగా ఉంటాయి. అక్కడ సీనియర్ సిటిజన్లకు అవసరమైన అన్ని సౌకర్యాలు కూడా ఉంటాయి.
ठीक है जी.
Yeah, I think it's just maybe give you guys a sense of how we think the world will evolve as a co-pilot for both web and app. I think, like I talked about, there's a bunch of work that's happening overall on the telephony side. There's a lot of interesting applications if you're able to provide contextual assistance as part of web and applications. And how you power this under the hood itself has a lot of things in terms of can you pass the page? How can you think of API-based knowledge transfer to the agent? How it can do interactions? As you go forward, I think there are also places where can you automatically apply a coupon code? Can you convince the customer to be able to make the transaction, etc. These are just a couple of places to give you guys a sense of maybe where things are with respect to telephony agents and web. I covered them in very small pieces, but just so that we see something real before we talk about what we mean by telephony agents and WhatsApp agents. I'll just talk about maybe making this simpler in terms of what exactly happens when you say something, right? So first of all, there is a user audio. User said something. User said something like, "Hello, am I speaking to Swiggy in audio?" The first part of this pipeline is called ASR. ASR stands for Automatic Speech Recognition, which is what we talked about before. What it is taking is it is taking this audio signal and then it is making it into a text line, which is "Hello, am I speaking to Swiggy?" Think of this like just subtitling your audio conversation. However, YouTube has subtitles. This is subtitling this. Once it gets this subtitle or this exact transcript of what you have mentioned, it is sending it to an LLM. The LLM has predefined rules. It has been told that, hey, you know what, this is how you should respond, this is what you should answer. If you have played around with GPT, think of this in a very simplistic way as your system prompt existing. So it has been told that when customers come this, you do this. So the LLM outputs another piece of text that says that, hi, this is Swiggy's AI assistant. Once that is there, we again want to respond back to the customer in audio. So we send this back to a model called TTS. TTS means text to speech. So this is speech to text and this is text to speech that converts and makes an audio out of this. Just think of this like an MP3 file or WAV file that is streaming. And then the user gets to hear this. This is the simplistic thing. There is audio converted to text gets the response, and this text is again converted back to audio in a very layman terms. If you think of conversational agents only, which is non-voice related ones, then you just have an LLM component. You don't need an ASR and TTS component. You just get the thing, you query your LLM, you get the response, and you show it back to the user. One extra level of complexity that happens when you're thinking of building for India is that we actually have language as a very big thing, and people are comfortable in very different languages. So the additional layer that comes is translate, which is your audio actually comes to Hindi first. So it's not even an English audio. So you have to transcribe this properly. You have to figure out which language the user is speaking automatically on the fly. And you have to do that. So the user says, "हाँ जी, ये Swiggy है क्या?" And then you translate it into English, which is, "Am I speaking to Swiggy?" Then you have to have LM, which is, "This is Swiggy's AI assistant." Then it gets translated back into Hindi. "हाँ, ये Swiggy का AI assistant है." And then you convert it into an MP3 and then you have to send it. So it actually has this 5 different components where every audio chunk, everything that the user is saying passes through. And you want to be able to do it somewhere between 0 to 900 milliseconds. Each of them are different models. Like your speech model, these would be your speech models. They are diffusion-based architectures. And then you have your LLM, which is a transformer-based architecture. And then it goes through all of these hoops before you see the response. This is a bare minimum thing. Again, at each of these places, there are some tricks. There is something that's happening. I'll cover through maybe some of them on what does it mean for each of them. Just for critical context, each of them are separate models. Like this is one model, this is another model, this is another model, and the final output before you get actually is a stringed output of each of these models that are being done together. Um, yeah, maybe before I go to that, just from a Sarvam context, the models, each of those models are built from Sarvam in-house, but there are a lot of other third parties where you can go and build voice agents that use third-party models. I've not mentioned Sarvam here everywhere, but whatever everything that we are doing at Sarvam is trying to build all of these models foundationally up, and we have the best accuracy in terms of Indian languages. We have the best accuracy in terms of instruction following. So for speech recognition, commonly available third-party models are OpenAI, Whisper. You can go ahead and you can try this out. You can think of building small applications or as part of voice agents. You can get started with these. Azure also has models. The main challenges that you will face is that when your audio size is very, very small, so the user just says hello, the user just says acha, the models struggle to do that. But if you have a sentence like, हाँ अच्छा मेरे को ये ठीक लग रही है, when you have a longer context, each word is being supported by what is being said before and after, so the accuracy keeps on improving based on if the length is getting increased. It stops after some length, let's say up to 2 to 3 minutes the audios are good, after that it's not so good, etc. So you have to figure out chunking, but that's the typical problem that you have. The second bigger problem is background noise, multiple people speaking, covering for accents. There's a very, very big challenge across the industry today. If you use OpenAI's voice mode, if you use Gemini's voice mode, when does it try to remove background noise? When does it get interrupted? When does it not get interrupted? Is still a very big struggle. The other thing is voice activity detection, which is these are not cases where you click on something like start speaking and after you're done, you click on end speaking, right? The AI model that's listening should automatically figure out that hey, this person has stopped speaking. And it's a very tricky balance because when are you waiting for pauses? When are you waiting for silences versus when is the speech actually done? So voice activity detection is a very big part of research in terms of trying to figure out voice agents. And then you have to figure out language performance. So speech recognition is the first step. And I would also say is one of the most critical steps compared to the rest of the ones. This is where you really have to get the what the user is saying right. If you get this wrong, all other subsequent steps that happen after this are going to be wrong and your voice agent is not going to perform well. So if you're trying to build voice agents, try to pick a provider where your speech accuracy is very, very high. Test out this level of the stack first and try to figure out what's happening. Today, also, I think across the entire architecture of voice agents, this continues to be the most important part and something where I think we need one or two more unlocks for it to become really, really seamless. The second one is translate layer. We talked about I got the speech, then I have to translate. You can think of Google Translate being the thing. Earlier you had translation models specifically. Today you can use an LLM to just translate. The tricky thing again is how you're going to let's say translate filler words. For example, in Hindi there is a word called acha. There's not an equivalent translation that you will have across languages. There are a lot of words that are available in English for which the equivalent things does not exist in Indian languages. Similarly, a lot of words exist in Indian languages that don't exist in English. So people are still trying to figure out what is the stack that they want to use. Sometimes things are hard coded, sometimes new things are being added, etc. Like I said, the advantage that we have at Sarvam in general is that I think we are working on the from ground up. We have a huge language team that's available that's actually studying languages, how do pronouns work, how do adverbs work, how do you create training data, how do you create for example idioms and phrases are things that are very, very language specific. So when there is an idiom or phrase that's outputted in English, what is the equivalent that you say in Tamil, for example? Those are things that are very important when you think about the translation layer. Then you have the LLM layer. Most of today's discourse on overall agent building is happening on this layer, rightfully so. It's the place where you're trying to figure out how your voice agent should work. So someone said something, someone said that hey, I want to cancel my flight ticket. You got your speech recognition done for that. You got your translation done for that. You're now thinking about what is the right set of action. All the instructions, RAG, tools, handing over to a human agent, all of that layer is effectively happening here. The main constraints and the main things that you want to keep in mind are what is the complexity of the task that I'm asking an LLM to do. That is very, very important. Narrow context tasks are done well. The more you get into the more complex tasks that you get into, you want to choose between the size of models, which is let's say Llama 8B versus Llama 405B versus Llama 70B, which model is going to be right for me. It is going to be done on experimentation. There is no framework right now to say that this works well here, this works well here. So the choice of model is very important. The prompts that you write are very important. How do you choose between RAG versus tool calling versus prompting is techniques that people are trying to figure out in this overall area. And how do you integrate with, let's say, telephony, etc., which is the person on the call is saying something like, hey, can I speak to a manual agent? So the LLM is getting this request, the user wants to speak to a manual agent, then it has to connect this entire call with the previous history to a manual agent. Those are some interesting problems that are being solved in this space right now. And like I said, I'm guessing most of the things that I'm hearing other people spend time on is how do I build small RAG agents, how do I build small tool calling agents. So the learning that you're doing there applies in this LLM layer. Then you have the last layer, which is the LLM has responded, then you reverse translate it. So I've skipped that. And you have the text to speech model, which is the LLM has said that this is the right response. And then you want to convert it back into speech. Typically, again, the main players that are doing this outside of Sarvam are 11 Labs and Whisper. The main areas of research that are going on here, the key problems that are being tackled here is voice cloning, expressiveness. Expressiveness is the most important reason why people drop off in conversations. The minute it sounds robotic, most people are not interested in conversing with a bot. They don't want to know that it's a bot. So any company that's working on this, if you're building your own voice agents, try to figure out how you can make it expressive, sound human-like. Spend that extra 1 to 2 rupees or 5 to 10 cents on getting an expressive voice. It really pays off. And then how are you able to do this across languages? It's also tricky in terms of there's a lot of problems to be solved on the text to speech side, which is, for example, it has to know when to read something as an abbreviation versus when to read something in full. For example, if there's a word like Aadhaar, it has to read it in full. If there's a word like ABHA, it has to know when it should read it out as ABHA versus ABHA scheme. So the ability for it to figure out that there is something called as f of x. How do you train a model, because you're not going to write f space o space x? How do you train it to speak out mathematical instructions? How do you train it to speak out abbreviations? How do you train it to speak out, let's say, uh, date of births, and any of these specific integer schemas that you have? Those are things that are still being solved, but I think these components are the main pieces where you go into building voice agents. There is the speech recognition, then translation, then LLM and TTS. There are already players that provide each of these models individually, so you can go open up a Python notebook, write out a small 3 to 4 line ASR code, translate code, LLM code, TTS code to build your own voice agent today. If you want to be able to get started with building your voice agent, I've given some examples of plays that you can use. All of these models are also available for Sarvam on APIs for free. So you can also stitch together an voice agent today by yourself in under 40 to 50 lines of code by stitching together all of this. The alternative that you can do is you can actually build out voice agents for yourself. I'll just maybe talk about that in 1 minute. Okay, I'll just maybe cover this and then I'll go to maybe how we can build a voice agent today simply. The first thing, and I think there's a lot that's happening, is what are the main challenges in building out voice agents today? One is you want to figure out the scope of what you can do. For example, if you start out with a scope that says that, hey, I will automate Paytm's customer service. Paytm's customer service is very broad. They have flight tickets, they have mobile recharges, they have maybe movie booking and everything and loans. It's going to be very, very hard. Today's agents are very, very good at solving narrow context use cases. Don't try to increase your context too much. Typically something that solves for one specific thing. For example, a good example is I have done my mobile recharge, I've paid for it, it said the transaction is successful, but it's not showing up in my phone. For example, I've not received the balance. That is a good narrow context assistant. Even there are going to be so many nuances. Is it Airtel? Is it Geo? What is the signal that you're getting from the telecom provider, etc.? Scope your agent very well. That's the first most important lesson that I would say. Otherwise, you will try to build a lot of things. It looks good for POC. You won't be able to get it into production because the complexity makes it very hard for the agent to follow instructions. Second, prompt writing is genuinely hard. You can go to OpenAI, you can write a few prompts, you can get an agent working, but to get it to work at production level, you really have to make sure that all the details are right. LLMs are very, very sensitive to each word that you write, which means if you write, say, if you write something like always greet the customer pleasantly, um, it could be interpreted like for every message that the user says, it will always say, hello Manikanta ji, hello Praveen ji. For every message, it's going to say that. So usage of words like always and never. How do you instruct it to do something? How are you going to give strict instructions versus liberal instructions? There is a lot that needs to be figured out. Spend a lot of time in prompting and writing. It's not like I've written an instruction, it's not working, so I'll not do it. You have to really get to what a lot of people are now putting out cookbooks. OpenAI has a prompt cookbook, Claude has a prompt cookbook. Spend your time going through it. They've already figured out what works and what doesn't. You want to go through it in terms of figuring out what is working and you want to get it. Third, latency is a challenge. I already talked about these 5 steps and how latency is tricky to get through. Four, today voice agents don't have a recursive learning loop in the sense that you deploy a voice agent, something is out in the wild, it's having a conversation with a customer. How awesome would it be if there is another LLM that's looking at this and saying that, hey, in this conversation, these 3 places it went wrong. And then it goes and changes the prompt to handle that edge case that it was not handling earlier. This doesn't exist today. So the learning that's happening from 10,000, 1 lakh conversations is not fully happening as quickly as it should be. Some companies like Sarvam and other people are investing into it, but let's say there are no open frameworks available outside. But this, once it exists, will help you go from voice agent 70% accuracy to 90 to 99 very, very quickly. Within, let's say, 1,000 conversations, you will be able to get to 99.5% accuracy. It's a very important thing that I think will come out. Toolkits are not available. I'll talk about this a bit later. Sixth, and this is where I think there are opportunities for new product thinking, new design thinking, which is the UI has now changed to be what is this conversation? How do I make it more engaging? The user is dropping off after the second step. How do I change my question? For example, there's this one company that had a very, very interesting experiment where initially, I think when we start about the first thing that we say, right, which is that, hi, this is Neha calling from Swiggy. Is it a good time to talk to you? This other company did a very small experiment, which is they just did something called as the first message was just hello and nothing else. And so the user on the other side was like, hey, hello, can I know whom I'm talking to? And that improved the overall conversion rate a lot. The minute we said something like, hi, this is Neka calling from Swiggy, the drop-offs are extremely high. The first turn drop-off in this overall thing seems to be very important. It's the equivalent of bounce rate in website. So how you solve for that? But how do you think more deeply about this conversation? Where is the user going? How do I ensure continuity? How do I ensure this overall experience of conversation being good itself is a place that we are seeing some people come out. There are new roles that are coming up in this area. They're called conversational designers. Conversational designers are going to think about what voice will suit for some use cases, what ambient noise will exist. How do I think about the conversation design? Like initially, I want to make sure that there's not a lot of friction. Then I want to come to a specific place where I get 2, 3 inputs from the customer. Then I'm going to be very salesy, etc. There's some research happening here internally. There's a bunch of people who are trying to work on this. These are interesting things that again I think people can spend time to being able to figure out. Then what I will do is for you guys to get started on agents. First, I will remove the complexity of voice. Let's just say that, hey, I want to build an agent where I send in a message and I get a response. And you can plug this into WhatsApp, you can plug this into other places, which is the LLM only part. What you can do is you can go to let me go here. Yeah, this is platform.openai.com. You can just go here. No credits required. You don't have to be a developer. You can forget about all of this. It's a very simple platform. Just go here. And then you have something called as Playground. In Playground, you can try a bunch of things. One of the things where what you can try out is building out assistants. So you can just go to assistants and you will be able to create your own assistant. They give you $5 free credits so that you don't have to pay or use credit card to get started. You can directly get started. Let me just uh, uh, build a dummy assistant, right? So let's say I'll say interview bot helper. You are here to take product and interviews. Start by asking a question. So it's just a small assistant that you're able to build out. You can build your tools. If you want to explore RAG, file search exists where you can upload a file and then it will answer from that. I'll just show an example of that also. But you can choose all of this. How do you want it to respond, etc. Just choose all the defaults and then you can get started. So I say something like hello and
Money, quick time check, 8 minutes before we
Yeah,
open.
I don't think I'll be able to finish in 8 minutes. I'll try to go till 10:55 maybe.
Sure.
Okay, sorry. Hey, let me try it again. Okay, just give me 1 second. I'll try to see if there's another place where I can keep that. In the meantime, if you have any questions, you can just keep dropping them in the chat
Yeah.
and then I'll pick them up.
So I'll probably call out a couple of interesting ones, right? So guys, like we'll go through this quickly and we'll probably open up an offline way of answering some of these questions. But quickly, can I talk about evals for models? Yeah.
Okay, got it. So then I'll just maybe go through this. I'm not able to present it. Actually, let me just walk through so that you guys can go back home and then try to figure out. I'll have to figure out what happened in billing. But basically, yeah, you can go and create an assistant like this. This is the easiest way in which you can actually think of building an assistant. This basically gives you an element of what is a conversational part of it only. We remove the previous speech and post speech wala thing. Just say that, hey, I want this to respond in the way that I can. I would encourage that anyone who's building assistants start from here, get to a level of confidence here that hey, my agent is doing the kind of stuff that I want. If you're familiar with RAG, you can use file search. I actually had applied a thing that I had done, but because we are not able to do that, I'll not be able to showcase. But basically, what I've done was try to take. I've created a credit card specifically for applied AI folks from HDFC. I just used GPT to create this. I gave this as a context within the file here. And once you give the file and you're able to engage with it, it will respond you in the context of that file. This is a specific text to text agent that you can think of that you can build and a good starting point that I would suggest. Once you see this working, you can go to real time where you can actually build out real time APIs. Let me see if this is something that I'm able to get it to work. Yeah, okay, cool. So what this gives you is the option in which you can actually try out voice agents. You can just give a system instruction here. So interview me about product management, and you can choose different voices. You can add functions. You can choose different models. And then once you do that, you can actually build out an end-to-end voice agent here. It takes just about 5 to 10 minutes for you to get to building your first voice agent product. And when you do this, OpenAI is already doing inbuilt ASR, it's doing inbuilt text to speech, speech recognition, everything that you only have to worry about what is the instruction and what is the conversation design, which you can define completely in your system instructions. And you will be able to go from an idea to a completely existing functioning voice agent in a few minutes. Once you see that this is working fine and you're comfortable with Python, you can also just take this as a WebRTC. These are all available within the OpenAI's documentation, very straightforward to implement. It will be about 10 to 12 lines of code for you to be able to take this and then put them in your own website, put them on Exotel, Plivo, any of these telephony providers. I wouldn't say that these are production grade, but these are very good starting points for you to explore what these systems are, how they work, how do you think about interruptions, how do you think about giving instructions, etc. These are two places that I would suggest. Go to assistance to build out the text assistance part of thing. I would say this to be the first starting point. After you're comfortable, add the complexity of voice, and then you build out a real-time application. And the third step is once you feel comfortable about this also, go through the documentations where they have ways in which you can deploy this very simply within 10 to 12 lines of code on any of the surfaces that you want. Then I'll go back here and then I think I'll get to, I wanted to cover the voice agent part also, but because of billing, I'll just, I'll let you guys explore it after this. And then we talked about evals and other things. So we talked about this layer, right? Which is that, hey, you know what? I will put all of these models together. I will go to OpenAI. I will do this. What you want is not just the agent, but you want things around it. And today, these things are still being formed. The overall ecosystem of products is still being formed. The right way to think about it is think of your website that you were building very early on when you had web development was supported by a bunch of things. You had analytics products like Mixpanel, Post-Hog, Amplitude, Google Analytics that existed for you to understand what's happening on your websites. Those sort of things are still evolving for LLMs, which is what conversations happen. Where is the drop off? How many users are retaining? What is average session duration? What do you mean by session duration? How do you look at, let's say, pauses, user speaking time versus bot speaking time? The overall analytics as a concept here is evolving. There are a bunch of players that are already doing this telemetry and observability in here. Good startups are coming up. Still, I think that people have not fully thought through in terms of analytics and observability, and I think we will see this new startups that are coming up in this space. And I think it's going to be very big because everybody will use agents in some sense. The second, and I think within analytics, think of it like two, three things. One is business insights, which is in this conversation, what did people say? You wanted to, let's say, sell credit card. How many people bought credit card, did not buy credit card? Why it happened? Why it did not happen? How many people had issues with the price of the credit card? How many people had could not take it because their salary was lower than the limit, etc. These are important for business folks. Then you also have these general things, which is like average session duration, number of turns, etc., which is the which are more relevant to the builder persona. Then you have testing and evals go hand in hand. I would put testing as something that's happening before you deploy something into production, which is you wrote an agent and you're trying to figure out, hey, is this doing well or not? Again, as part of Sarvam, when you're writing out agents, we already provide you with a test suite. It actually tests your overall thing, etc. But you want to figure out, hey, I wrote a specific instruction, whether it happened that way or not. There is manual testing and then there is automated testing. Manual testing is most prevalent today. People are taking manual calls. So before you deploy something into production, companies are putting in internal employees to take calls, about 30 to 50. You build conviction and then you scale. So it's going in a slow way. Automated testing is very, very useful because getting to the right product is very, very iterative. And you can't just keep asking people to take these calls, etc. Automated testing can do 10,000, 12,000 tests. It can answer like a person who is like 5-year-old, who is 8-year-old, who does not have interest in the use cases, someone who is saying something like, I'm very busy, can you call me back later? Someone who is saying, I'm not interested in your product. It does all of these things and gives you confidence on whether this voice agent is good enough to be deployed or not. The last one is evals. Evals is again a very, very untapped area. Amongst these three, we have some work that's being done on observability, some work that's being done on testing. Evals is very untapped. Everyone is trying to figure out how evals should work. Uh, so there are two things two ways in which you can think about evals, which is I evaluate each model separately. I evaluate my speech recognition. I evaluate what my LLM is saying. I evaluate my text to speech, and I figure out how the accuracy of each of these things are. The second way in which you say is I don't care independently about each of these things. I want to evaluate from a user point of view. So I don't actually care about all of this. I just see what was the conversation that happened, and then I will use a judge model to be able to do evals. Coval is one company that's playing in this space. Secura is another company that's playing in this space. Most of the full stack builders like Sarvam are building this in house. So let's say after 1 lakh conversations, after 10,000 conversations, we have a judge model. So you have this conversation that happened. Then you have a third party model called a judge model. This judge model does not have context of your prompts. It doesn't. It has context of the business use case though. So it knows what does success or failure look like, and then it goes through all of these conversations to identify the right ones, identify the wrong ones, flag which are the ones that have issues, flag which ones had hallucinations, toxic behavior. For example, the user end was using some explicit words, flag for silences, in how many cases the agent not respond or went rogue, flag in how many cases user were asking out of context questions. Like, for example, you built an agent for flight booking, someone is coming and asking things like write a Python code. So how do you able to figure out of context things? And then it's also evaluating the quality of answers, whether they're responding in the instructions that were shared, whether they were according to the brand guidelines that that you have defined, whether it's making the API calls relevantly or not. So there's a bunch of overall things that need to be done on evals, which is how is the conversation quality, whether it's doing what it's doing or not, brand tonality, and everything. So there's a lot of work that's happening there. And I think, like I said, amongst all of these three, evals is the most underlooked area right now. And if you are someone who can actually build good evals, that itself is a big superpower. Most PMs that are operating at a model layer, one of the first things that they actually do is start thinking about evals. So when we want to hire product managers for our evals as a product, etc., or for our model building as a product, which is building speech models, building LLM models, we don't start with PRDs. We look for these people's ability to write evals. And uh, one good reading point for this is recently Lenny Rachitsky has put out a series of YouTube videos and reading materials on why evals are going to be the most important things. OpenAI has also put out documentation around why evals are the most important things for product managers to learn. So if you're a product manager wanting to get into model side, I would suggest that you start thinking about evals and how you can think of better. The world really needs much more higher quality evals. Any other questions that are there before I move to next steps?
Yeah, one interesting question I saw is can you share the breakdown of how to achieve this 900 milliseconds latency in terms of ASR, LLM, TTS, like the translations, etc.
Understood. Got it. There are easy and hard ways. The easiest way is just use small models everywhere. They have very small latency. You have models that just have 50, 60 millisecond latency also. So that's getting this 900 is not the hard part. If you use small models, you will be able to get them. Except that they will come at the cost of performance. So the harder part is trying to figure out what you will do on your engineering orchestration side that help you do this. It's not the model itself. The model is something that's working backwards from performance as an objective. So the model continues to remain. You will try to figure out some tricks around distillation to make sure the model is more performant even with smaller parameter size. How are you co-locating all of your models within the same GPU cluster is very important so that you're not having this geographical latency or latency that's happening between servers. Caching is a very interesting thing, and you can think of caching being again an overlooked area in terms of how you can achieve latency. The third one is streaming. How do you not wait for the user's input to be over to start generating output? Just when the user is already starting to say his first sentence, all of that input is already going into the LLM and you're going to get out. Fourth, I would say is it's a lot more of software magic than the LLM model magic. Getting latency down has a lot to do with your understanding of how did you orchestrating your systems better, and how you're cutting down latency obsessively for each millisecond.
And how does the split look like in terms of percentage time taken by each of these steps?
Yeah, I think LLM continues to be 40 to 50% of the thing, and the rest are smaller things. Translation is smaller. Speech models typically are higher. So maybe 50% is LLM, 40% is speech models. Both speech models combine speech to text and text to speech, and 10% would be translate.
Got it. Kind of switching gears to in terms of practical adoption, like companies using it in production for real use cases. Where are we on that curve?
Yeah. So today, someone has deployed voice agents for Aadhaar. So every time you're a customer of Aadhaar and you're calling regarding changing of your phone number, changing of your name, address, you're calling the Aadhaar customer care. It's the entire Sarvam stack that's powering those conversations, and that's as much close to production ready as we can get. It's the largest system in India. It touches millions of customers, and we have been able to deploy successful agents there. We have deployed. I think there are companies that have multiple companies that have crossed tens of millions of calls from voice agents, Seven being one of them. And I think it comes down to the previous things that I said, which is how do you think of narrow context assistance and spending a lot of time in prompt writing and understanding the tricks. We have seen really good application. We are working with Swiggy, for example, on hiring delivery partners. Just the sheer volume of calls that they do in Bangalore is about, I think, 5 lakhs per month or something like that. Just one city for one use case, only food, only Bangalore, only delivery partner hiring. So there is a lot of use cases that companies have, and I think there are companies that are already demonstrating to do this at scale. I get the general sentiment in terms of time taken for it to deploy being longer, and I think that's it. I think we have been able to go from 2 months to 2 days or something like that.
And how is the customer feedback like? Like, is it a viable replacement for humans calling today, or do you think we'll have to progress a little bit more?
Correct. So yeah, most of the customers, and that's what our learning has also been, that don't think of this as an alternative to humans. For example, we work with a company that actually does welcome calling for customers who are, for example, taking four-wheeler loans. So if you take a four-wheeler loan, after your loan is like completed the document signing, you get a voice agent that calls you and then confirms these details for you. This is actually a very, very big use case. But they want to be able to do this for two-wheelers also, but they can't do it because it's very expensive and their ROI doesn't make sense for it. So we see that it's not that it's actually a replacement, but it's actually now providing better experience to customers on a broader range of tasks. So we see this augmenting people. Obviously, there are some companies that would say that, hey, you know what, the ROI is making sense. Can I use this for four-wheelers, etc. And that's up to the company to make choices. But from a end-to-end conversational handling, we do see higher percentage conversion rates for the same intent from human to AI being higher and at a lower cost. And we also, at maybe 50% would be the cost saving for companies. Conversion rates uptick. For example, if manually the conversion rate is about 3 to 4%, you would see AI agent somewhere between 2.7% to 4.5%, depending upon the use case, the complexity, etc. And then there are these other things in terms of the fact that it's very elastic. You want to go from 1,000 orders to 1 lakh orders. You necessarily don't have to go through your scaling up your fleet or firing of your fleet, etc. It gives you the possibility to be super elastic.
It's very interesting. Yeah, I mean, if the conversion rates are comparable already, then opens up a lot of opportunities.
Yeah, like I said, conversionist or comparable is also maybe trying to be a bit conservative. Some of the use cases that we have seen probably have 2x in terms of conversion rates for people continue conversations. Um, yeah, I think that's on that. Yeah, I think I'll just maybe talk about what are the next things that needs to be unlocked in this. The first thing is voice to voice. I think the bet is that people currently having to tie ASR, TTS, LLMs. I think we will start to see that change. I think by the end of this year or by the first quarter of next year, I think we will see just voice-to-voice systems coming out. Anyone who's interested in the architecture side of things can just go in and then maybe read up about it. What does it mean to take audio tokens in, audio tokens out? Where is the reasoning happening? Where is the tool call happening? There's a lot of interesting things that are happening there. The second thing is cross-platform. Today we see only telephony, only WhatsApp, only in-app. I think we will see two, three things happen. One, can I guide you on a call while you make some things on the phone? So can I say that, hey, I want to help you with filling a form or an Aadhaar KYC? So you get a phone call, and the phone call may one of the first thing that the agent says is, I've sent you an SMS with a link. Can you open that? And when you open that, it's guiding you step by step. हाँ आप यहाँ पे phone number enter करो, आप यहाँ पे OTP enter करो, etc. So we'll see that happen, and that seems to be a very interesting direction and very promising. But also, I think it opens up possibilities for you to have the same context with a business, not just from a from one surface but across surfaces. So, for example, even if you're thinking about building voice agents or conversation agents in the form of a friend or a companion or a relationship advisor sort of thing, most of these people are trying to figure out, can I also be present on WhatsApp? Can I also be present as an app? Can I also be present as a telephone? So how do you think of one long range context or personal record of a user is one place where we will see this evolve. Third thing is increased memory. Today, I think these are good. These calls are somewhere good between a conversational length of 1.5 minutes to 4.5, 5 minutes. You will see this crack. For example, if you have a specific use case that is more than 20, 30 minutes, the ability for an LLM to have that much level of context because of token limit, etc., is very hard. We are seeing now models come with 1 million context length. Also, the overall retention of information is very small. I think as this starts to happen, we will see very long context agents. So today, if you call a voice agent and then you call an agent the next day, how much of you are able to remember your history is very limited. But I think we can imagine a place where you're like, when you call an agent the next time, it knows all the last 25 interactions that you have had with it. So it knows your preferences. It's getting started very easily. It knows about the order ID that you have spoken to the last time. It knows about whether you're a prime customer or not prime customer. Why did you not take Swiggy one that you spoke about 13 calls back? And if something has changed, then it's able to use that information right now. So memory unlock will mean that you'll have a lot more personalized engagements. Then broad context assistant, which is instead of one mobile specific recharge, we'll see one agent being able to take care of the entire customer care. I think that will start to be in sync. Fifth, today business owners, product managers have to write very detailed instructions for how your voice agent has to work. I think we believe that how your product should work has already been written in code. It's available in GitHub repos, the logic, what is a new customer, non-new customer. The ability for you to be able to be in sync with developer documentation means that when a new feature is developed, can the voice agent automatically know how to steer this conversation, whether something is possible, not possible, etc. So I think that is one place where things will evolve to. And yeah, I think generally I'll share these reading materials async also, which is there's a bunch of good VC insights on where voice agents are going to go. But I covered a lot of it from the perspective of business to customer use cases. There's a lot of this friend/companion voice agent use cases that are coming up. There is a lot that's happening in the form of a teacher, mentor, guide sort of a thing, helping you teach stuff, etc. On WhatsApp, there is a lot of people building very interesting things. For example, spirituality related things. Can you talk to God? And then someone who actually helps like answer Bhagavad Gita, etc. So those are some interesting applications. Faith tech is now very interesting. Astrology has a lot of applications. So I genuinely, maybe for you guys, voice agents are being used across a bunch of industries, lots of interesting applications, lots of interesting research problems, and not just on the voice agents, but ecosystem that's being built around it has a lot of opportunities.
Perfect. Super. So we are over time. Is there a good place to end or anything else you have to?
No, I think that's mostly what I wanted to end. And
super. Awesome, Vinny. Thank you so much. This was actually quite useful. Could we share this PDF with the group?
Sure, sounds good.
And is there a place? I know people can check out Sarvam AI in their website, sarvam.ai. Is there a way they can actually reach out to you if they have if they want to connect?
Yeah, please do ping me on LinkedIn. The reason I kept this less about Sarvam was our platform is still not exposed publicly. We're working with some of the large enterprises, but we have not put it out publicly. So I would have loved it for all of you guys to have go and build out on the Sarvam platform, but maybe in due time we'll be there.
Very soon. Yeah. Super. We'll also share some of these questions. I know we didn't cover all of them. We'll share some of these questions offline and get the answers from super awesome, guys. Thank you so much. Thanks for spending this Saturday morning with us. Mani, especially thanks to you. This was extremely useful at this point. I have a lot of understanding on voice agents now. Super. Take care, everyone.
Awesome.
Thank you, Mani. Bye.